All right, so the instructions got cut off on this one. The instructions are solve by factoring. So we're given these equations, and we have to solve for x, meaning what values of x will make the equation equal 0. Numbers 9 and 10 are like another video I just did. The only difference is that there's a coefficient in front of the squared term. So like number 9, for example, if we come here, remember what goes on top is a times c, so 7 times negative 3 is negative 21. On the bottom is 20. The right combo for this would be, we'll do positive 21 and negative 1, right? Because 21 times negative 1 is negative 21. 21 plus negative 1 is 20. Perfect. Now I can't do the shortcut here because, like I just said, the 7 is in front of the squared term. So I just need to break, so this is a very traditional factoring by grouping problem. So I'm going to change the 20n into the two numbers I just got here. So it's going to be 7n squared plus 21n, because it's a positive 21, minus 1n, because it's a minus 1, and then minus 3. So I just rewrote the original problem, and all I did was split apart the middle term. Group the first two and the last two, and take out a GCF from each parenthesis. So I'm take out a 7n, I'm left with n plus 3. Here, I take out a negative 1, I'm left with n plus 3, because when you take out a negative, it changed all the signs. Parentheses match, perfect. So it's going to be n plus 3 in the first parenthesis, and then the GCFs go in the other one, 7n minus 1. Now I have the factors. Now I can set each piece equal to 0. So n plus 3 equals 0, which again, that will give me n equals negative 3. 7n minus 1 equals 0, which if you do all the arithmetic, will give you 1/7. Okay, so those are my two answers for number 9. Okay, so number 10 will follow the same suit. Again, just make sure you use the x factor to get to the different pieces, and then once you get the different pieces, set each piece equal to 0, and that's the zero product property. So 11 and 12, not to throw you off, but notice how this is a key thing that you have to recognize. See how 9 and 10 are set equal to 0? I can't x factor, or I can't factor any equation until it's set equal to 0. So notice how number 11 and 12 don't get tricked, because you have to first set the equation equal to 0. So for number 12, we would actually add 4 to the other side, which would give me 2n squared plus 11n plus 5 equals 0. Now that the equation is set to 0, now I can do the x factor, because if you didn't do that, you wouldn't get the right answer. You'd think, oh, it's prime, I can't factor it. So on the top is 2 times 5 is 10, in the middle is 11, the correct terms are 10 and 1. Again, there's a number in front of n squared, so we need to actually do the traditional grouping, so 2n squared plus 10n plus 1n plus 5, and again I get the 10 and the 1 from the 10 and the 1 from the x factor chart. Group, oh, of course set equal to 0. Take out a 2n, leave me with n plus 5. And whenever you do this process, you have to take something out, even if it's a positive 1. So I'm left with n plus 5, because taking out a positive 1 but doesn't change a thing. Parentheses match, n plus 5. GCFs go on the other parenthesis, 2n plus 1. And then if I set each part equal to 0, I'm going to get n equals negative 5, and n equals negative 1/2, or my two answers for this equation. So, again, I left out 10 and 11 specifically. I gave you examples here. If you need a deeper example, I did another video that you can take a look at, but these would be when it doesn't easily factor with the x factor chart, or a isn't 1, and you have to use this technique, the whole grouping technique, to get to the final answer.